This tutorial has been provided to explain how to model and design massive flat slab using MIDAS Gen 2015. There are 3 tutorial videos for modeling, analysis, designing, and this is the first part for modeling. Now we are going to model the structure from the start page of MIDAS Gen 2015. Click the new file on the top of the screen and save this file. First of all, check the unit system at the bottom of the screen. Load for kilonewton and length for meter I'm going to use. So in order to create the model, we are going to use the line grid in this time. Go to the structure and grids, define line grid. So give the name for the line grid and enter the size that you want for the Y direction as well. So now you have line grid on your screen. So once you generate the line grid, you can easily grab the intersect line, so we can easily generate the model. Go to the node, create the node. So simply click the 4 nodes, and then we are going to generate the column on these positions. So in order to do that, go to the material properties. So we are going to define the properties for column first. So column will be concrete. I'm going to use the standard data for properties and go to the section as well. Define the section for your column. I'm going to use this rectangular shape. So give the size for the column. Now you have your material and section for your column. So in this time, we're going to use this extrude function to generate the column. So column will be generated by node to line element, and you can select the material and section here, and distance you can manually type. So -0.5 and select the all nodes and click apply. So now you have 4 columns on your screen. So I'm going to generate this position as well. So in this time I'm going to copy these 4 nodes, 4 columns to this position. So go to the translate and select all columns that you just created and give the distance. You can manually enter the distance, but in this time you can just select the distance here to here. So I'm going to copy 3 times and click apply. So now you have 16 columns on your structure. And the next step, we are going to generate the beams in order to generate the automated flat slab. So in order to do that, we are going to define the section first. In this time, I'm going to give the null for name and round shape. So give the really small size for imaginary beams. And go to the node element and create element. So select the section we just defined and generate the beams. We can manually generate all the beams along the line grid, but in this time I'm going to copy these beams. So go to the translate and select the beams and give the distance and give the times. But in this time we have to check on this intersect option, because we need to intersect these vertical beams and horizontal beams. So click apply. Now you have these beams, and same manner we are going to generate the horizontal as well. So give the distance and click apply. Now you have all beams on your structure. So from now on we don't need the line grids, so I'm going to toggle off this line grid. And next step, you're going to generate the meshed flat slab. So go to the node element and mesh it and auto mesh it. So slab will be generated by the line elements we just created, and select the quad triangle type and give the mesh size. And we have not defined the thickness for our slabs. So in here you can just simply define your thickness. And click apply. So we have to select the line element. So click this select by plane and click all the line element and click apply. And now you have your slab on your structure. If you want to see the thickness of your slab, go to the display option and you can check on the frame thickness and plane thickness. So as you can see, the thickness will be displayed on the screen. So if you do not want to see the nodes, you can also inactivate the nodes like this. And if you see this thickness of flat slab, the column and the flat slab is duplicated in this position. So in order to move this flat slab, we are going to use the offset option in the properties. Go to the thickness and click modify. Here we have this option flat offset. So thickness ratio, I'm going to give the 0.5 ratio. So a thickness will be moved to this position. So now it's not duplicated in this position. I'm going to inactivate the nodes for our convenience. And to better explain, I'm going to give the different color for column and slab. So in this time we are going to distinguish these two elements with this material type. So go to the material and just copy the same material type and give this column to the new material. So now you have two material type. So go to the display option and draw. The element color will be displayed by global color or element or material. So in this time we're going to use this material color and click apply. You can see this material color. Now it's the same, so we are going to change this in color tab and material. This is the slab color, so give some color you want and edge color as well and blend. And column as well, I'm going to give gray color for this and blend as well. So now you can see the color is changed. So we can easily distinguish the column position and the flat slab. Next step, we are going to define the domain. the flat slab is divided some domains randomly. So this is not in order. So just delete all the domains except 3 domains. We're going to define the new domains for this. Select all flat slab and give first domain. Now you have the domain is defined for all slab. And select the slab between the columns position. And give the second domain. Now it's divided into divided into 2 domains. And the last, I'm going to give this position for third domain. Why we are doing this? In design procedure, it's easier to distinguish the domain area for each reverse. So give these third domains here. So now you have first and second and third. So also we can specify the names for this. So I'm going to do this for S1. Click modify, and this one for S2. Click modify, and this one F3. So S1 slab domain is this, and S2 and S3. And the next step, we are going to give the boundary condition at the bottom of the column. So select all the nodes under the columns and go to the boundary and define support. In this time, I'm going to give this pin condition. So now you can see the dx and dy dg is constrained. And the next step, I'm going to give the load. So first, we are going to define the static load case for self-weight, dead load, click add, and dead load as well, click add, and live load. So first, give the self-weight for -1 to z direction, and the slab load, we are going to use this pressure load. So change the live load and give -8 kilonewton per meter square, and select all the slabs and give the load.